Peer into the abyss of time, a universe still in its infancy, just 280 million years after the Big Bang. The cosmic darkness had barely begun to lift, and the first galaxies were kindling their light across the void. In May 2025, astronomers unveiled a groundbreaking discovery. MoM-z14, the most distant galaxy ever observed, captured by the James Webb Space Telescope, JWST. This galaxy's light embarked on its journey across the cosmos just 280 million years post-Big Bang, reaching us now as a whisper from the universe's infancy. The findings were led by Rohan Naidu, an astrophysicist at the Massachusetts Institute of Technology, and published on May 23, 2025, on the preprint server RRXiv. MoM-z14, identified through JWST's infrared sensors, boasts a redshift of 14.44, surpassing the previous record holder, JADE's GS-z14-0, which had a redshift of 14.18. Redshift is more than just a measure of distance, it is a measure of time itself. The higher the redshift, the older the light. And at this extreme, we're brushing against the boundary of the known universe. A redshift of 14.44 translates into light that has traveled for over 13.5 billion years, revealing an era when the universe was less than 2% of its current age. The discovery doesn't just extend the cosmic frontier, it redefines it. Despite its distance, MoM-z14 is remarkably compact, only about 240 light-years across, roughly 400 times smaller than the Milky Way. Yet its mass rivals that of the Small Magellanic Cloud, a nearby dwarf galaxy. This implies a galaxy undergoing furious and efficient star formation, condensing matter into stars at a pace that defies conventional expectations for such an early era. The process by which such a small galaxy could achieve so much mass so quickly is a matter of intense interest. MoM-z14 likely experienced a burst phase of star formation, where conditions allowed gas to cool rapidly and collapse under gravity into clusters of young, hot stars. These high-mass stars live fast and die young, enriching their surroundings with heavier elements through supernovae. This enrichment process fuels subsequent generations of stars, embedding the galaxy with a complex chemical history, one that is already apparent in MoM-z14's spectral signature. What makes MoM-z14 especially intriguing is its chemical fingerprint. Astronomers detected a nitrogen-to-carbon ratio similar to what is seen in globular clusters, dense, ancient star groupings that orbit galaxies like our own. These clusters are relics of the early universe, and their chemical composition reflects the generations of stars that came before. That MoM-z14 mirrors these ratios implies that similar star formation and enrichment processes were underway even at the cosmic dawn. This kind of chemical signature is more than a curiosity, it's a cornerstone of galactic archaeology. Nitrogen is a product of intermediate mass stars, while carbon is forged in more massive stars. The observed ratio hints at the types of stellar populations that existed in MoM-z14 and the time scale on which they lived and died. In a galaxy only a few 100 million years old, the presence of these elements implies that multiple stellar generations had already come and gone. Its brightness is another mystery. To shine so intensely this soon after the Big Bang suggests that either MoM-z14 contains an extraordinary number of young massive stars, or perhaps, hidden at its heart, lies a black hole contributing to its luminosity. Supermassive black holes are known to reside at the centers of most galaxies, but their existence in galaxies this young presents a profound cosmological puzzle. How did they grow so quickly, and what mechanisms fueled their early formation? Such discoveries are possible only because of JWST's advanced capabilities. Orbiting at the L2 point, a million miles from Earth, JWST operates in complete darkness, shielded by its massive 5-layer sunshield the size of a tennis court. Its 6.5-meter mirror, made of beryllium and coated in gold, collects infrared light from the farthest reaches of space and time, enabling astronomers to detect signals no other instrument can see. JWST's instruments, like NIR-CAM, NIR-SPEC and MIRI, allow astronomers to peer through cosmic dust and pick up the red-shifted glow of ancient stars. These sensors are cooled to just a few degrees above absolute zero, preventing any thermal interference that could mask faint galactic signals. It's a marvel of precision engineering, a telescope built to see the invisible. Before JWST, telescopes like Hubble struggled to capture light from the earliest galaxies. The universe's expansion stretches light into the infrared spectrum beyond the reach of visible light telescopes. But JWST, with its infrared sensitivity, can pierce that veil and bring those first galactic flickers into focus. MoM-z14 builds on a string of successes. JWST previously uncovered JADE's GS-z13-1, a galaxy existing just 330 million years post-Big Bang. These discoveries reveal that the epoch of ionization, when light from the first stars ionized the intergalactic hydrogen, was well underway by that time. MoM-z14 pushes this timeline even earlier, suggesting the universe was becoming transparent sooner than thought. Alongside distant galaxies, JWST is also spotting supermassive black holes from this ancient epoch, some with masses equivalent to 1 billion suns, formed when the universe was less than 1 billion years old. Their existence challenges existing theories that predict far slower black hole growth. These cosmic titans raise difficult questions. Did they form from massive primordial stars, or through runaway mergers of smaller black holes? Or is there an entirely unknown mechanism at play? As we uncover more of these ancient structures, another pattern is emerging. The early universe may not have been a gradual build-up of complexity, but rather a rapid, chaotic and energetic explosion of galactic activity. MoM-z14 represents just one data point, but it sits at the edge of a growing constellation of anomalies that challenge our cosmological assumptions. And the future promises even more. The upcoming Nancy Grace Roman Space Telescope, launching in 2027, will perform wide-field infrared surveys that complement JWST's deep but narrow views. Roman will chart vast areas of the sky, helping astronomers understand whether galaxies like MoM-z14 are rare anomalies or just the tip of an iceberg we're only beginning to glimpse. Roman's broader field of view will allow researchers to construct large-scale galactic maps of the early universe, helping to place individual galaxies like MoM-z14 into a broader evolutionary context. Was MoM-z14 part of a larger structure? A proto-cluster of galaxies forming in the earliest web of cosmic filaments? Roman may soon provide the answers. The synergy between JWST and Roman will be transformative. One telescope sees the finest details in the deepest dark. The other paints the broader cosmic landscape. Together, they'll give us both the forest and the trees, filling in the gaps in our knowledge of how stars, galaxies, and black holes came to be. MoM-z14 is a beacon from an ancient epoch, a flare from a time when the universe was raw and young and full of violent energy. As we gather more data and refine our models, this single point of light may serve as a Rosetta Stone for understanding galaxy evolution, chemical enrichment, and the growth of cosmic structures across billions of years. In the meantime, each light signal like MoM-z14 is a cosmic telegram from a universe long gone, carrying messages that rewrite textbooks and expand imaginations. These are not merely scientific observations, they are stories written in starlight from a time before Earth even formed. As we continue to peer deeper into the cosmos, each discovery like MoM-z14 serves as a time capsule, revealing the universe's secrets from epochs long past. Somewhere beyond the veil of space and time, more ancient signals await, flickers of creation from the dawn of everything. Will we be ready to hear what they have to say? If you're captivated by the mysteries of the cosmos and the groundbreaking discoveries reshaping our understanding of the universe, subscribe to our channel. Join us on this journey through space and time as we explore the frontiers of astronomy and beyond.